Hello everyone, this is Peter from Learnwithuncletee, and in this tutorial we are going to be discussing minimum and maximum value problems. So firstly, let's start from the keywords first. We have the word minimum and we have the word maximum. Basically, a synonym of the word minimum is the word least. We can use lowest, so a synonym of the word is minimum. A synonym of the word minimum is least. We can use lowest and a wide variety of other words. A synonym of the word maximum we can use the word greatest. We can use the word highest and a lot of other words that can still replace the word maximum. Now, basically, let's start from the concept of quadratic equation because that's one of the preliminary topics where minimum and maximum value problems are first been discussed. Now, take a look at this. The general form of a quadratic equation is y is equivalent to ax squared plus bx plus c. Now, when you plot a quadratic graph, it's either you have a U-shaped parabola or you have an N-shaped parabola. Now, let's consider these two parabolas. For example, if we have a U-shaped parabola, let's draw a simple graph. Now, consider this graph. If these are y positive, or let's just say our y-axis, and this is our x-axis. If we have a U-shaped parabola, the graph goes in this form. Now, for you to have a U-shaped parabola, basically in quadratic equation, you know that your a is going to be greater than 0, which means a is a positive number. Now, if your a is greater than 0, and what is that a? It's still from that general equation, which is ax squared plus bx plus c is equal to 0. So when this a is greater than 0, you get a U-shaped parabola. Now, a U-shaped parabola simply means that only minimum value is going to exist. There's no going to be maximum value. And what does that minimum value simply mean? It simply means the word least from what I've discussed before. So now if you take a look at the base of this U is sitting on the base, and that base is that minimum point. So this point, if you take it back to the y-axis, this gives you your what? Your y minimum. Now, the value of x, the value on the x-axis that will give this minimum point is also the same thing as, is that same point that will give you your equation of line of symmetry. For example, let's draw a line of symmetry for this curve. So if this is the line of symmetry for this curve, this is the value. At this point, there's a value of x that will give this minimum value. And that equation of line of symmetry is given as x is equal to minus b over 2a. From quadratic equation, there's a formula for minimum value, which is y minimum is equivalent to 4ac minus b squared, everything all divided by 4a. Now, we are going to take this in relation to, because we are discussing on the application of differential calculus. So you really need to understand the connection, because the same way when they tell you to find the minimum value or the maximum value under quadratic equation, you can also make use of application of differential calculus to solve your answer. Now let's consider a quadratic equation. Let's say that we have a quadratic equation y is equivalent to x squared plus 5x plus 6. Let's say our y function is equal to 0. That is x squared plus 5x plus 6 is equal to 0. From this, our a here is going to be 1. So it means our a is 1, our b is plus 5, and our c is 6. So if we introduce it into this formula, we get y minimum to be equivalent to 4 times our a, which is what? 1, times our c, which is 6, minus b squared, 5 raised to power 2, which will give us 25. Everything divided by 4 times our a, which is what? 1. So y minimum here therefore gives us 4 times 6, that's 24. 24 minus 25, that will give us minus 1, divided by 4 times 1, which is what? 4. It means the minimum value for this question will be y is equal to minus 0.25. So what it therefore means is that, assuming this was the graph that gave us x squared plus 5x plus 6, at this point, the value of y at this point will be minus 0.25. You know that where the curve cuts the x-axis, those are going to be the two values for x. For this quadratic equation, the two values of x will be minus 2 and minus 3. So which simply means that this U shape will completely fall at the negative side of the x-axis. So now, considering the minimum value formula, that's from quadratic equation, and also considering the value of x that will give you that minimum value, here, our x will give us minus b over 2a. Our b is 5, so this will give us minus 5 divided by 2a, which is 2 times 1, which will give us 2. So which means that the value of x that will give us that minimum value is going to be minus 5 over 2. So now, how can we now relate these to differential calculus using the application of differential calculus? Now, in relation to differential calculus, there is what we call turning points. Turning points. Now, one of the first things that you need to know is that maximum and the minimum points are turning points. And turning points can also be regarded to as stationary points, because in a way, if we are to discuss, okay, let me write that down also. Stationary points. As the word implies, stationary, that is, if you take a look at this curve, this U shape, when it gets to this minimum point, it appears to be stationary before it now changes direction back up. So, categories of stationary points includes maximum points, we have minimum points, and we also have point of inflection. You can get point of inflection when you have a graph that contains minimum points and maximum points at the same time. So, though we are still going to go into that in a more detailed tutorial, so let me just write that down. Point of inflection. Now, one of the first things that you need to know about stationary points is that at every stationary point, your dy dx is going to be 0, which is your derivative. So that's like the most important remark. At every stationary point, the y dx is going to give us 0. So it means that the gradient at the stationary point will be 0. The slope at the stationary point is going to be what? 0. Now let me illustrate this much graphically so that you understand what I'm saying. So now, this point, if I call this point A, if I call this point B, if I call this point C, A, B, and C, they are all stationary points. So at stationary points, your derivative is equivalent to what? To 0. So now let's apply this concept now to this quadratic equation, which is x squared plus 5x plus c. So now don't forget, let me rewrite it. The quadratic equation x squared plus 5x plus 6 is equivalent to 0. We got the minimum value using the formula, the quadratic formula before, to be minus 1 over 4. And we also got the value of x that will give us that minimum value to be minus 5 over 2. Now, using the application of differential calculus, since our y is now equivalent to x squared plus 5x plus 6, and at every stationary point, we know that the y dx will give us 0. So it means that if we are to find the y dx here, if we differentiate x squared, this will give us 2x. If we differentiate 5x, this will give us plus 5. If we differentiate plus 6, that will give us 0. So since the y dx is equivalent to 0, it means that 2x plus 5 will give us 0. So 2x plus 5 is equal to 0. Therefore, x will be equivalent to minus 5 over 2. Now, this is the same thing as the value of x, which is our equation of line of symmetry that we got when we used x to be equal to minus b over 2a. So, but this is now using the application of differential calculus. So now, to find the minimum value, as stated as from the question, the value that you have gotten, this is the value of x that will give us that minimum value. And we have our function already to be y to be equal to x squared plus 5x plus 6. And we also know that y is a function of x, which is f of x, will give us x squared plus 5x plus 6. So since this is the value of x that will give us the minimum value, it means that the function of minus 5 over 2 will give us the minimum value. So basically here, if f of x is equal to this and you're looking for f of minus 5 over 2, anywhere we see x, we are going to substitute minus 5 over 2. So this will give us minus 5 over 2 raised to the power of 2 plus 5 times minus 5 over 2 plus 6. So f of minus 5 over 2 is our minimum value, is equivalent to 25 over 4 minus 25 over 2 plus 6. So if we find a combined LCM here, that will be 4. So we're going to have 25 minus 50 plus 24. So 25 minus 50, that'll give us minus 25 plus 24, which is minus 1. And that'll give us minus 1 over 4, which is the answer that we have got before. So this means that the minimum value is minus 1 over 4. So this is the basic introduction to minimum and maximum value problems. As a remark, the formula, or let me say the formula y minimum, that is under quadratic equations that we used, which was 4ac minus b squared over 4a. This formula basically refers to both minimum and maximum values. For quadratic equation, the only difference is that for minimum, your a will be greater than 0. For maximum, your a will be less than 0. And when your a is greater than 0, a is a positive number. When a is less than 0, a is a negative number. Now, this is a quadratic equation. What happens when you are dealing with a cubic equation? Now, let's take a look at that. Now, let's consider a curve that is not a quadratic equation. For example, let's say that we have y is equivalent to x raised to the power of 4 divided by 2 plus 5 divided by 3 x raised to the power of 3 minus 2x raised to the power of 2 minus 3x plus 1. Now, take a look at this. This is a curve. Now, basically you can't use the quadratic formula here. You have to use your application of differential calculus. Now, firstly, we know that at minimum points, at maximum points, our dy dx will be equal to 0. So let's find the y dx. The y dx here is going to give us 4 multiplied by x raised to the power of 3 over 2. We are using the MS method. So that's 4 times the coefficient, which is still 4. So we have this, we subtract 1 from the power. So we have plus 5 divided by 3 multiplied by 3 x raised to the power of 2 minus 4x minus 3. And when you differentiate 1, that will give you 0 because it's a constant. So therefore, we have the y dx is now equal to 2 in 4, those will give us 2. 2 times x raised to the power of 3 will give us 2x raised to the power of 3 plus 3 will cancel 3. 5 times x squared, this will give us 5x raised to the power of 2 minus 4x minus 3. So basically, when you take a look at this, the y dx is equal to 2x raised to the power 3 plus 5x squared minus 4x minus 3. The y dx is equal to 0. That's the first condition. It means that 2x raised to the power of 3 plus 5x squared minus 4x minus 3 will now give us 0. So now, how do we know the value of x? Because you know that this is a cubic equation now. You don't know. This will give you 3 values of x. How will you know which value of x will be the value of x that will give you minimum? How will you know which one will give you maximum? How will you know which one is the point of inflection and the rest? So now, we have to solve this cubic equation, which is a polynomial. Now, let's try using the remainder theorem. Let's try factor of 1. If f of x is equivalent to this polynomial, which is 2x raised to the power 3 plus 5x squared minus 4x minus 3. If we consider f of 1, let's see whether it will give us 0 to check if 1 is a factor. So this gives us 2 plus 5 minus 4 minus 3 when your x is 1. So 2 plus 5 is 7. Minus 4 minus 3 is minus 7. 7 minus 7, that'll give us 0. So it means that x is equal to 1 is a solution to this. So if x equals 1 is a solution, it means that x minus 1 is a factor. So if x minus 1 is a factor, let's use the remainder, or we can use the long division to break down the polynomial. So now, what it means is that if we create a division, so we have the polynomial 2x raised to the power of 3 plus 5x raised to the power of 2 minus 4x minus 3 is now being divided by x minus 1. So x into x raised to the power 3, this will give us 2x raised to the power of 2. 2x raised to the power 2 times x, this will give us 2x raised to the power of 3. 2x raised to the power 2 times 1, this will give us minus 2x raised to the power of 2. So if we subtract, we're using the long division method here on our polynomials. 2x raised to the power 3 minus 2x raised to the power 3 will give us 0 here. 5x squared minus 2x squared, this will give us 7x raised to the power of 2. So divide again. X in 7x squared will give us plus 7x. 7x times x, this will give us 7x squared. 7x times minus 1, this will give us minus 7x. So don't forget, we'll bring down minus 4x, minus 4x. Then we subtract again. So again, 7x squared minus 7x squared, that'll give us 0. Minus 4 minus minus 7, that's minus 4 plus 7. And that's 7 minus 4, which will give us 3x plus 3x. So we'll bring down minus 3. Then we divide again. X in 3x, this will give us plus 3. 3 times x, this will be 3x. 3 times minus 1, that will give us minus 3. So when we subtract, 3x minus 3x will give us 0. Minus 3 minus minus 3, that will also give us 0. So here, this is our remainder. That's using the remainder theorem. This is our polynomial. This is our divisor. And these are our quotients. So of course, if you understand the general form of a polynomial, which is P is equivalent to dq plus r, our polynomial here is 2x raised to power 3 plus 5x squared minus 4x minus 3 is now equivalent to our divisor, which is x minus 1 multiplied by our quotient, which is 2x squared plus 7x plus 3 plus the remainder, which is plus 0. So what it means here is that, because I told you we are using the remainder theorem, 2x plus 3 plus 5x squared minus 4x minus 3 is now the same thing as x minus 1 multiplied by this. So we just need to solve this quadratic equation to get our 3 factors. So because we have one of the factors already. So if we consider 2x squared plus 7x plus 3 is equivalent to 0. The two numbers that when you multiply them together, you're going to get 6, which is 2 times 3. And when you add them together, you're going to get 7. So those two numbers are actually what? That's 1 and 6. Because 1 times 6 will give you 6. 1 plus 6 will give you 7. So using factorization, 2x squared plus 1x plus 6x plus 3 is equal to 0. So if we factorize x out, this will be 2x plus 1. If we factorize 3 out here, this will be 2x plus 1 is equal to 0. So when you group them together, this will be x plus 3 multiplied by 2x plus 1 is equal to 0. So what it means is that this polynomial is now the same thing as x minus 1 multiplied by this, which is now x plus 1. Sorry, not x plus 1. X minus 1 multiplied by 2x plus 7x plus 3, which we have factorized to be x plus 3 multiplied by 2x plus 1. So here we have gotten the 3 factors of that polynomial. So don't forget what we're actually trying to do here. The 3 factors are, let me bring this back. We have x minus 1. Let me write it here. So we have x minus 1. We have x plus 3. And we have 2x plus 1 as the 3 factors. So from here, so back to this polynomial, it means that when you solve this polynomial, if x minus 1 is equal to 0, your x will be equal to 1. If x plus 3 is equal to 0, your x will be equal to minus 3. If 2x plus 1 is equal to 0, your x will be what? Minus 1 over 2. So basically, how will you now know x equals 1, does it represent minimum or maximum? X equals minus 3, does it represent minimum or maximum? X equals minus 1 over 2, does it represent minimum or maximum? This is where the second derivative now comes into play. So now, you understand that since we have gotten our dy dx to be 2x raised to power 3 plus 5x squared minus 4x minus 3, it means we can find our second derivative. The square y over dx squared will give us, if we differentiate 2x raised to power 3, you're going to get 6x raised to power 2. If you differentiate 5x raised to power 2, you're going to get 10x. If you differentiate minus 4x, you're going to get minus 4. So it means our second derivative will be 6x raised to power 2 plus 10x minus 4. So now, when you now take your second derivative, when your x is equal to 1, your second derivative will give us the square y over dx squared to be, anywhere we see x here, we'll substitute 1. So that will be 6 times 1 plus 10 times 1 minus 4. And that's going to give us 12. So consider 12. Is 12 greater than 0 or is it less than 0? 12 is greater than 0. So because 12 is greater than 0, it means x is equal to 1 is going to satisfy minimum. Now, we'll repeat the same process. When x is equal to minus 3, you're also going to find your the square y over dx squared. So here you're going to substitute minus 3. So that will be 6 times minus 3 raised to the power of 2 plus 10 times minus 3 minus 4. And that is going to give us 20. So when the square y over dx squared is equal to 20, 20, is it greater than 0 or is it less than 0? It's greater than 0. So it means minus 3 is also going to be what? A minimum point. Now, minus 1 over 2. So when x is equal to minus 1 over 2, we repeat the same process. This will give us 6 times minus 1 over 2 raised to the power of 2 plus 10 times minus 1 over 2 minus 4. And this will give us the square root over the x squared to be minus 7.5. So since the square root over the x squared is equal to minus 7.5, minus 7.5 is less than 0. So it means that for minus 1 over 2, this is going to be what? A maximum point. So it means that in this question, if you are told to find your maximum value, the maximum value for this question, you're going to use x to be equal to minus 1 over 2, in which you substitute in the first equation, which is that curve itself. So here you have something like 1 over 2 times minus 1 over 2 raised to the power of 4 plus 5 over 3 times minus 1 over 2 raised to the power of 3 minus 2 times minus 1 over 2 raised to the power of 2 minus 3 times minus 1 over 2 plus 1. So, but if you are told to find the minimum value, for this question, you are going to have two minimum values. So basically, this is the first part on minimum and maximum value problems. In the next tutorial, we are going to dissect the second part under the minimum and maximum value problems. This is Peter from Learnwithuncletee. See you in the next tutorial.